Now the meaning of heat treatment is heating a metal or alloy to various definite temperatures holding these for various time and cooling at various rate. That is heat treatment. So you can say heat treatment is heating, then holding, and then cooling. The combination of such processes, we call it as heat treatment process. The combination of controlled heating and cooling determine not only the nature and distribution of micro constituents but also the grain size. Okay, so you can say the combination of these techniques impact on micro constituents, okay, as well as on the grain size. Now, this change of micro constituent further impact on the mechanical properties of the material. The purpose of heat treatment is number one, to remove or relieve strains or stresses from the material. Now, these strains or stresses are induced within the material by cold working, okay, or they are induced by non-uniform cooling. Okay, so during welding, non-uniform cooling takes place. So at that time, there is induction of strains or stresses within the material. So to remove those strains, to remove those strains or stresses induced, we can use the heat treatment process. Now, the name of heat treatment process that we use for removing these stresses or strains that we call as annealing. The second purpose of heat treatment is to increase the strength of the material or the hardness of the material. Okay, so this improved hardness result in wear resistance, that shows improved wear resistance. Okay, So this we can do with the process named as hardening. The another purpose of heat treatment is to improve machinability. So this we can do with the help of annealing. Another purpose is to soften the material. So again we can use annealing process. Another purpose of heat treatment is to decrease hardness and increase ductility and toughness. Okay, so this we can do with the help of tempering process. Another purpose is to improve the cutting properties of tools. That we can do with the help of hardening. And another purpose is to change or modify the physical properties of the material so such as electric properties, magnetic properties, corrosion resistance, okay, and heat resistance, etc. So to improve such properties, we can also use various heat treatment processes. So these are the purpose of heat treatment. Now next we see what are the various types of heat treatment processes. So basically we have two types of processes. One which works on the surface of the material, and second one are which works on the bulk, or you can say on the complete material from the surface towards the interior one. Okay. Now the bulk processes, these are annealing, okay, then normalizing, another one is hardening and tempering, another one is mar tempering, there is one more heat treatment process that we call as Ost tempering. Okay. Now further we have different annealing processes. So the one is full annealing, another one is recrystallization annealing, another one is stress relief annealing, and one more annealing process, that is spheroidization annealing. Okay. Then the various surface heat treatment processes are, the one category is of thermal processes, another one is thermochemical. Okay. Now the thermal processes, these are like flame hardening. Okay. Or by using flame, we can heat treat the surface of the material. Another one is the induction process. Okay. Then we have laser, and then we have electron beam. So by using these processes, we can heat treat the surface of the material. So that are the thermal processes. Then thermochemical processes, these are like carburizing, one process. Another one is nitriding. Okay. And another one is carbonitriding. Okay. So such are the thermochemical surface heat treatment processes. So these are the various heat treatment processes we have. Now, as we seen earlier, the heat treatment is deal with heating. Okay, so heating at certain temperature and then holding that material at that certain temperature. So we have different range of holding temperatures for different heat treatment processes. Okay, so we have different holding temperatures for different heat treatment. So these are called critical temperatures. These holding temperature we call as critical temperatures. Now from the iron carbon diagram, we have eutectoid temperature. So that is something like this. Okay, so this is my A1. So along here I have temperature. Okay, so here I have uh, iron. So now this point, along this point, my eutectoid reaction takes place. Okay, so this A1 temperature we called as a isotherm temperature, that is eutectoid temperature. So this A1 is my eutectoid temperature. Okay. Now I have another temperature range along this line, that is my A3. This temperature range is my ACM. Okay. Now this temperature range of A3, that is along the phase boundary between austenite and a two-phase, that is austenite plus ferrite. Okay, so this is my gamma range. Okay, this is alpha. Okay, so in between I have gamma plus alpha. This is my two-phase region. Okay, and ACM. So along this line, any temperature that is at phase boundary between austenite and two-phase. So those two phases are austenite plus cementite. So here I have gamma plus Fe3C. Okay, so the various temperatures for different heat treatment processes you can write as. Okay, so here this one is normalizing. Above this A3, I have the normalizing process. Okay, then here also I have annealing. Okay, so this line is corresponding to 0.8% of carbon. Okay, this is for normalizing. Okay, so for this region here I have the annealing. Okay, so near about A1 or below A1, I have the temperature range for spheroidization. Okay, for recrystallization annealing. Okay, and then for stress relieving. Okay, so these are various holding temperatures for different heat treatment processes. So we also discuss them again in detail when we discuss various heat treatment processes.